Hey guys, welcome to D3. From Pandas to PySpark. Comparing Python Pandas and Spark data frame is something which we would want to start before learning or going deep into PySpark. If you have already done some work in Python, chances are that you have come across Python Pandas. It is a go-to library for data analysis in Python. It is extremely easy to use, flexible, and very popular in the world of data science. But there is a catch. Pandas work great when your dataset fits into the memory for a single machine. Once you move into the world of terabytes and petabytes of data, welcome to data engineering. Pandas alone can't keep up. That's where the Spark data frame steps in. Spark data frames are declarative, and they have been built uh, with inspiration from Python pandas. They are almost similar to Python pandas. Today we'll make our first real bridge from pandas to Spark by comparing pandas and Spark side by side. By the end, we'll be able to realize that why Spark data frames are the natural choice for data engineering. Pandas, the familiar background. Whatever we are seeing is a code that where we are trying to build out a data frame in Pandas. It's a Pandas data frame, a simple Pandas data frame, and we are trying to calculate the average of that average of revenue by region. We are trying to calculate that. This entire code is using Python Pandas. This works beautifully for few rows. You can quickly filter, aggregate, and visualize. All the functions are directly available. In the function above, we are doing mean. On the similar lines, you can do filter, aggregate, visualization. But there is a limitation. What if the CSVs has 10 million rows or 20 million rows and requires 20 GB of a RAM to process? Your laptop is only having an 8 GB of RAM, and Pandas inherently doesn't have capability to split and parallelize the operation. It wasn't designed for distributed computing. Here comes the Spark data frames. Spark data frames are built for scale. They, even though they look similar to what a definition of Pandas data frame could be, here you can see that we are creating a Spark context, and we are simply calling a function called create data frame by passing data and columns, and we are getting Spark data frame created. But inherently it creates something called RDD, which is a resilient distributed data set which can be distributed across multiple machines, which pandas can't do. And the operations like calculating the average, filter, aggregate, and all those things can be performed across the cluster. That is the beauty of Spark Scala. That is the beauty of Spark. It looks very similar, but the difference is Spark doesn't care if there are 4 rows or 4 billion rows. The data is distributed across machines, and Spark execute them in parallel. If we try to do a smaller comparison in terms of scale, pandas can work only in single machine and if everything fits into the memory. So if your size increases, you can take a machine with a larger capacity, but eventually there will be a limitation. Whereas Spark has the capability to distribute the data across the cluster and scales to petabytes. Execution. Uh, Pandas have their implementation called eager, which runs immediately, whereas Spark has lazy evaluation, which builds a plan and then execute only on the action. It creates internal DAG and then executes on action. In terms of ecosystem, data analysis, visualization, small medium workloads, Pandas is good. Even for machine learning datasets where the data is already aggregated and in a very smaller quantity compared to what data can be at the initial stages, pandas are good enough. For Spark, we have an ecosystem where we need an end-to-end pipelines, ETL, streaming, machine learning, every other type of use cases. We need Spark. Syntax similar, surprisingly similar by design, but Spark wanted to make a transition from pandas very smooth. So even we have the function called to Pandas, which can help to convert the data frame to Pandas. Or Pandas data frame can easily be converted to DF by just calling a single function called toDF. Why this transition matter? As a fresher, we may love to have a simple Python pandas libraries and much easier to work with, but data engineering, when we deal with actual data sets, it's not just few millions of rows. There can be billions of transactions coming in, and therefore the data size could be enormous. We may have to analyze the decades of financial records. In such cases, definitely Python pandas is not the answer. It simply cannot handle. That's why understanding before understanding Spark data frame, it is crucial that we understand Python pandas. There are few hybrid use cases as well. Interestingly, we don't have to abandon pandas completely. In many projects, we may use both. For example, we can use Spark for large dataset ETL and aggregation, convert it into a small resultant dataset, and then we can use Python pandas and its exploratory and plotting libraries just to showcase the dataset or to analyze the dataset. Pandas is a great library for smaller to medium data on a single machine. Spark data frames is something which is or Spark is built for a distributed computing. Even though the syntax looks similar, Pandas knowledge transfer easily to Spark. In practice, data engineers often have this question, right? Like why I if I can do it with Python Pandas, why I need to learn the Spark framework and that entire complex structure? So this is the answer to it. If you want to scale, then the only option available is Spark. Think of Pandas as your bicycle, great for short trips. Spark, on the other hand, is your high-speed train. It gets you across the country. Both are useful in data engineering, but you will mostly be riding on the train. That's the day 3. You have just taken the first real step into learning the need for Spark. Spark data frames are the bridge between the between the analytics between the big data and analytics. In next day 4, we are going to go deep into what is Apache Spark and its architecture. Even though the syntax and everything looks similar to what Python pandas are, how uh, Spark internally works and behaves, that that we are going to learn in depth in the next video, where we are going to see the architecture and functioning of Apache Spark. Thank you for listening into this. We'll uh, quickly move to the next day, where we are going to learn Apache Spark. Thanks. Thanks. Please do subscribe. Thanks.